Hello, this is Mr. Collier, and today we're going to be solving equations or systems of equations by graphing. Okay, in the first example, we've got a system of equations, also called simultaneous equations. We've got two of them here. We're going to graph them and see where the point of intersection is going to be. So your first line, your slope is 3 or 3 out of 1, and your y-intercept is -4, so that's very easy to graph. Here's -4. Slope is 3 out of 1, so up 3, right 1, up 3, right 1. You can keep going like that and making points for your line, and the opposite direction is down 3, left 1. Okay, and then I'm going to draw a line connecting those dots. Okay, so there's my first line. And the second line, we have slope equals -3 out of 1. Y-intercept equals 2, so I'm going to start with the y-intercept of 2. Slope is -3 out of 1, so that's down 3, right 1, down 3, right 1, down 3, right 1, and so forth. And in the opposite direction too, up 3, left 1. Okay, then I'm going to draw my line, and you can already see where they intersect. Alright, they intersect at this point right here, which is the point 1, -1. Okay, so that's the solution to this system of equations, 1, -1. If we look at another example, okay, in this example we've got two equations. So the first one, we have slope equals 1/3, y-intercept equals 1, so I can start at the y-intercept of 1 and use my slope of 1/3, so that's the rise of 1, a run of 3, so that's up 1, right 3, up 1, right 3, and go the other direction, down 1, left 3, down 1, left 3, down 1, left 3, and I can draw my line. Hopefully this straight line tool works. There we go. And my second line, we have a slope of -1, which you can write as -1 out of 1, and a y-intercept of 5, so I can start off at 5. Slope -1 out of 1, so go down 1, right 1, down 1, right 1. You can already see where the point of intersection will be. Okay, I'm going to draw my line anyway. Okay, oops. Okay, let me draw that line using this tool. And you can see where the lines intersect is going to be this point right here, which is 3, 2. So the solution to this system of equations is 3, -2. Okay, let's look at a real-life example. Now these are not straight lines, but this is what happens in real-life examples often. The red line shows Japan's GDP over time, and the blue line shows China's GDP. So there's a point in time when China's GDP became greater than Japan's GDP, and we can see where that point is going to be. It's going to be the point of intersection. Okay? So if you look closely here, that's about in what year? This is 2005, 2011, so that's about maybe 2009. So when did China overtake Japan in GDP? In about 2009. Okay? About 2009. Okay, the next example we're going to solve by graphing. We've got two lines here. Let's look at the first one here. We have slope equals 2, or 2 out of 1. And there's no y-intercept, so we can say that the y-intercept is 0. So the y-intercept is 0. Slope is 2 out of 1, so I go up 2, right 1, up 2, right 1, and so forth. And I go backwards as well. So that's a line with slope of 2. Going to graph the line. Okay, next. Now this line, there's different ways to graph it, but one thing we can do is we can change it to y equals mx plus b form. Okay, so we just want y here, so we can subtract 2x from both sides, and you've got y equals negative 2x minus 4. So the slope is negative 2 out of 1. The y-intercept is negative 4. So I can start off at negative 4, and then go down 2, right 1, down 2, right 1, and so forth. And I go backwards this way, up 2, left 1, up 2, left 1. And you can see where the point of intersection is going to be already. Okay, so I'm going to draw on that line. Okay. And technically you should draw, should draw arrows on these lines to indicate they keep going forever. Anyway, here's the point of intersection, which is negative 1, negative 2. So your solution to this system of equations is negative 1, negative 2. Okay, one final example. Here we have two lines. The first one's not in slope-intercept form, so let's change that to slope-intercept form. So we have x minus 2y equals 4. We can subtract x from both sides. Negative 2y equals negative x plus 4. Then I have to divide by negative 2. So you're going to have y equals, and I'm going to have negative, this is like negative 1x over negative 2, so that's going to be like half x. And 4 divided by negative 2 is negative 2. So your y-intercept is negative 2. And your slope is half, so I can go up 1, right 2, up 1, right 2, up 1, right 2, and so forth. Down 1, left 2, so I can make all these points. And connect the dots. And for my second line, it's already in slope-intercept form. Slope is half. Y-intercept is 1. So the y-intercept is 1 and the slope is half. So I go up 1, right 2, up 1, right 2, up 1, right 2, and so forth. And in the other direction, same way. And I'm going to connect the dots here right now. So notice in this example, the lines do not have a point of intersection. Okay, they do not have a point of intersection. They're actually parallel lines. And that happens when you have the same slope in the two equations. So these lines don't meet. And what that means for the solution is that there is no solution. There's no point x and y that satisfy both equations. There's no point of intersection. So in this question, the answer is no solution.